Okay, so this is a walkthrough of the review on 8.1 through 8.4 that you will be quizzed on. And so my suggestion for this video is it's probably going to be much longer than your usual videos. So I would suggest fast forwarding, rewinding until you get to the questions that you need explanations on instead of watching the entire video front to back because it's going to be so long. Okay, so with that being said, let's get in and start with the first one. Okay, so your first two problems ask you for the sum or the difference, and so we said in each of those cases we are going to add or subtract the coefficients when the variable and the exponent of both of the terms match. So this is really just combining like terms. I'm going to say 2 minus 8 is negative 6. I am not going to change the exponent. That's going to stay as a 7. Same thing's happening in the second problem, saying 2y to the 5th minus 4y to the 5th. I can combine those. 2 minus 4 gives me a negative 2. Y to the 5th is just going to stay the same. I'm not going to change that at all. Okay, so that's just a combining like terms problem, and you're going to use that later when you have to add and subtract larger polynomials. Okay, so problem number 3, it's asking you to write the polynomial in standard form and name the polynomial based on its degree and its number of terms. Okay, so remember we said standard form meant that you can't have any like terms that are not combined, and then we are going to put the exponents in order from the highest exponent down to the lowest exponent, and then the constant term will be last. So if I'm taking a look at this, it looks like if I'm scanning through the problem, I see squareds really are the highest of the exponents, and I have 2 of them. So I'm gonna in one big shot, I'm gonna move these to the beginning and combine them together. So I'm gonna say negative 11 plus 6. Well, that gives me a negative 5, and again, don't change the exponent because we're adding and subtracting. Right, and then minus 8x to the first doesn't have anything to combine it with, so I can bring that down. And then positive 2 I'd write on here as plus 2. Right, so I combined and then I put them in order. Now it goes exponent of 2, exponent of 1, constant term, which means the one that doesn't have a variable is at the end. Right, so that's the first part. That's putting it in standard form. Now it's asking us to name the polynomial based on its degree and its number of terms. So I'd say this is a degree 2 because this has a highest exponent of 2, and we call degree 2 polynomials quadratic. So I'd say this is a quadratic polynomial. And then based on its number of terms, I see 3 parts. Negative 5x squared, negative 8x, and 2 are my 3 parts. Whenever I have 3 parts, I call it a trinomial. So I'm going to say this is now in standard form, and I have given it a name. It's called a quadratic trinomial. Okay, so after this, problem 4 and 5 are asking you to add and subtract polynomials. So we said whenever you're adding polynomials, just add like terms, combine all the like terms. So I'm seeing a 2y cubed and another 2y cubed, so I'm going to add those together and make it 4u cubed. Right, and then I'm going to do that with each of the terms. 6u squared, I'm looking, I don't see any other 6u squared, so I'm just going to add that on, 6u squared. And then my next term would be u to the first. I see a minus 7u to the first and no other u to the first powers, so I'm going to attach that on. And then 3 plus 6, well, that gives me 9. So my sum here is 4u cubed plus 6u squared minus 7u plus 9. Okay. Differences were the same thing, but we said we're actually going to distribute this minus sign into all of these terms. So instead of it being minus negative 7, we're going to say that's the same as if I added positive 7, and I added 5, and I added 9x. Right? So we changed all the signs on the inside by giving that negative to each of them. So now I'm going to go through, and again, when I'm going to do this, I'm going to start with the highest exponent I see, which is x to the 4th. Now this says negative 5x to the 4th. Plus 7x to the 4th, well, that's 2x to the 4th. Okay. Looking for x to the thirds, I don't see any. Looking for x squareds, I also don't see any. So I'm going to move on to x to the first. I see negative 7x plus 9x. Well, I'm going to say that's 2x. And then 5 plus 5 is 10. So I'm going to say this is the difference of these 2 expressions there. Problem number 6 is asking you to simplify the product. Remember, product is multiply. So this is just asking us to use the distributive property and to remember our exponent rules because they are going to apply here. So I'm going to say 5a squared times 3a to the fourth. Well, 5 times 3 gives me 15. And this is the place where we are going to change exponents. Because we're multiplying, exponents mean repeatedly multiplying. That's when it's going to change. This is going to become a to the sixth, 2 plus 4. 5a squared plus 3b, and I'd say, well, wait, a and b, those are different bases, so I can't combine those. So I'm going to say, well, I can do 5 times 3, well, that's 15 again. Okay, and then I'm just going to write a squared b, right? I can't put those together, I can't combine them, so I just put them next to each other. Instead, I'm going to multiply whatever a squared is and whatever b is. 5a squared times 2, well, that's just 5 times 2 is 10, and the a squared comes along for the ride. All right, so I would say this is the product. All right, I can do the same thing with the second one. I'm not going to use little arrows. We're just going to do it. All right, I'm going to say 8p times this first one would be negative 24p to the third, because remember there is a 1 here, so it's 1 plus 2 to give me a 3. 8p times 6p is going to be 48p squared, right? Because again, 1 plus 1 gives me 2. And then 8p times negative 2 is negative 16p. Right? So that would be the product using the distributive property of those two monomial and trinomial expressions. Okay? Problem 9 and 10 are doing the opposite of what we just did. Up here, I gave you a monomial and we multiplied it by a polynomial. Down here, when I ask you to find the GCF, I'm saying I distributed something to get this. What is that something? So your job is to tell me what is the common factor of these numbers and how many of the variables do they share that I can remove. So I'd look at 26 and 34 and I'd say, well, 26 has factors of 1 and 26. It also has factors of 2 and 13, and that's it. Right? These are the two ways that you can get 26. 34, very similar, 1 and 34. That gives me 34. 2 and 17, that also gives me 34. And that's it. There's no other ways to multiply integers and get 34, at least not positive integers. Right? So I'm going to say, if I look at these lists, the largest number that they share is this 2. That's the only number, the largest number that's in both the lists. So I'd say 2. And then when I'm looking at the variables, we said they have x's in common, so there's definitely going to be an x here. And now the question really is how many. So I'm going to say, well, this one has 2, this one has 4. They only have 2 in common because I run out at 2 in this first expression. So I'd say GCF is 2x squared, and that's all we have to write for this one because that's all they asked about. Problem number 10. I'm going to say, well, it looks like 48, 6, and 26. Those only have a 2 in common. I don't see anything larger, and you can go through and make a list for all of these to determine that. And I would say that the largest exponent is 2, so I'm going to say since they all have x's in common, I can take away just 2. And these ones actually had the same GCF. That was just a coincidence. That won't always happen. Okay. 11, 12, and 13 are asking you to factor the polynomials, which means let's find a GCF. But now we're also going to have to find what was the thing that we multiplied the GCF by to get each of these answers. Right? So let's start off with the GCF. In 11, I see 2 and 4 and 8. Well, they all have a 2 in common. And only 1x, because this last term only has 1x. I can't take more than just the 1. So now my job is going to be, how can I multiply 2x times something and get a 2x to the third back? Well, it looks like times x squared, right? That's my 2x's plus 1 more gives me 3. In order to get a 4 back from a 2, I need to multiply it by 2. And again, I have 1x on the outside, so I'm going to have 1x on the inside. And then how do I turn 2x into 8x? Well, that's just times 4. So I'd say that is now factored. Right? And that's going to be the same process that we do for each of the other ones, so I'm going to move a little bit more quickly through these. Common factor here is 5. I can remove 3 w's, so I'm saying 5w to the third. And then to rebuild this, 5w to the third, and that's again because here's 3 of them, and 3 more gives me 6 w's. 5 times 5 gives me 25. And I can do the same thing with the second part, just 7 in this case, because the 3 w's are on the outside. I only need to account for 3 of them, so I just really had to figure out how do I turn 5 into 35. Well, that's times 7. Okay. Problem 13. 54 and 9 have a 9 in common. I see c's in common. I can take away 3 of those because I run out of c's at 3 here. And I'm going to say they also have d's in common. And I can only take away 2 because there's only 2 in this spot, so d squared. So again, this one's going to be a little bit trickier. I have to turn 9 into 54. That's times 6. C to the third into C to the third. Well, I don't need any more C's inside. I have all three of them right here. D squared, however, has to turn into D to the fourth, which means I need to put those extra 2 D's right there. Next term, okay, I need to turn 9 into 9. Well, don't need to multiply it by anything but 1. Right, C to the third has to turn into C to the fourth, which means I need one more C. D squared to D squared, which means I don't need anything else, and that means that I'm done. Right? If you had a little 1 here, that's fine as well. I'm not going to write it in because we don't have to. So I'd say this is the factored version. Okay, when we move down to 14 through 16, they're asking you to simplify, and in this case the operation is multiplication. So what this meant for us was when we did binomial times binomial, or really any polynomial times any polynomial, it's just going to be distributing. So this is going to be 3h to both parts of the second one. So let's do that first. 3h times 3h is 9h squared. 3h times negative 6 is negative 18h. And now I have to do the exact same thing with my other one. I'm going to say this has to be done. Well, that looks like negative 21h. And when I do negative 7 times negative 6, that's a 42. Okay? And we said after that, you just have to combine like terms. I see negative 18h minus 21h. Well, that's going to be together negative 39h. And then the other parts just come down. 9h squared at the beginning and a positive 42 at the end. So I'd say this represents the product. Every other problem is going to follow this exact same pattern. So again, I'm going to go a lot quicker. I'm going to say that this one turns into negative 12h squared, negative 28h. When I come to 2 times 3h, well, that's 6h. And 2 times 7 gives me a 14. And now I'm going to combine the middle terms. I'm going to say negative 12h squared minus 22h plus 14. And I would say this is now simplified. Okay. Next problem. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. And then I move on. Negative 7 times 3x is negative 21x. Negative 7 times negative 5 is negative 35. Combine my middle terms, and I get 9x squared minus 36x minus 35. And I'm going to make a correction here. Negative 7 times negative 5 is positive 35. So there should be a plus sign here. Okay. Problem 17, same thing again, so I'm just going to write out the steps here. It looks like 6x squared minus 18x plus 8x minus 24. And then I can simplify that into 6x squared minus 10x minus 24. Okay. When we move on to 18, 18 is a trinomial times a binomial, but nothing's going to change except that we need to distribute 3 times now instead of 2. So I'm going to take 2n squared times both parts of this. Well, that looks like in the first one, 8n to the third minus 10n squared. And then I'm going to move on. 5n times 4n is 20n squared. 5n times negative 5 is going to be negative 25n. 3 times 4n is going to be 12n. And 3 times negative 5 is negative 15. And I just have more to clean up here. I see negative 10n squared plus 20n squared can be combined. So I'm going to bring down 8n cubed. This is going to become 10n squared, which came from negative 10 plus 20. And again, the n to the first can also be combined, and that's going to turn into negative 13n, and then minus 15 comes along as well. So I'd say this is the fully simplified version. Okay? Problems 19 and 20 are asking you to square a binomial. So let me remind you that this does not mean just square 2x and square 6 and you're done. What this actually means is we're going to say, let's expand it. 2x minus 6 times 2x minus 6. And then it's really just like the problems that we've done a bunch of, double distribute. 4x squared, and it looks like we're going to get 2x times negative 6, negative 12x. Another negative 12x, and a positive 36. Right, so again, when I combine the middle two terms, I get 4x squared minus 24x. Be careful about that. This does not cancel. right? That would be if there was a plus sign here, right? And then a plus 36, okay? Same thing for problem number 20. It's going to be 7m plus 5 times 7m plus 5, because that's what squaring means. And this is going to turn into 49m squared plus 35m plus another 35m plus 25. And I'm going to combine my middle two and say 49m squared plus 70m plus 25. And this would be the product after I squared. Okay? One more problem, and this is just asking you to write the area of the frame of the frame only instead of the picture. So let me draw you a picture of what this one looks like. All right, so it looks like they're saying we have a rectangular frame, right, something that looks like this. And inside of that, there's a picture as well. So obviously this is what frames look like. Right? So we'd say that's our rough sketch of a picture. So what this one is saying is that the actual painting, the actual frame has dimensions of x plus 2, and the width is x plus 4. And the picture itself on the inside has dimensions of x minus 6. That would be this little line just going from here to the other side, and x minus 1. And so what they really want to know is what is the total area of the frame, which would really be like if I just cared about this little outside piece here all the way around the border, and I wanted to know what was the area of just that. Okay? That's what we're trying to find. So we said this is a shaded region problem. In order to do these types of problems, we're going to find the area of the big rectangle, right? Kind of pretend like that small one's not there. Well, in order to do that, it's just length times width. So I'm going to say x plus 2 times x plus 4. Okay? So let's forget about the second one for a second. Let's multiply all this out. I'll let you do that, and I'm just going to tell you that it's x squared plus 6x plus 8. Okay, so you can do that middle step where you combine and see that you do get a 6x. Okay, the area of the painting itself, or the picture, is going to be the same thing. So I'm going to say x minus 6 times x minus 1. Well, that's going to be x squared minus 7x plus 6, which again I'll let you go through and do multiplication. So in order to find the area of the shaded region, we said find the area of the big one, which we did. That's this expression. Subtract away the area of the little one, and what's left over is the shaded region, which for us is the frame. So really what I'm saying is area of the big one minus area of the small one. Now that I have these simplified, I can say there's one minus, and there's the other. So I'm going to subtract these. We said subtracting polynomials involves turning this into addition and then distributing inside and saying instead of positive x squared, let's make it negative. Instead of negative 7, let's make it positive. And instead of positive 6, I'm going to scribble that out. Let's make that a minus 6 instead. Okay. So now I'm going to go through and combine. I see x squared plus negative x squared. That's 0x squared, which cancels out. 6x plus 7x, well, that's 13. And then 8 plus negative 6, well, that's going to be a 2. Right? So I'm going to say this expression, 13x plus 2, represents the area of the shaded region. Long video.